Hi everybody, Denny here from ColdQuanta. Welcome to 3 Minutes of Quantum Computing. Last week we finished converting the 8x8 StarBattle puzzle to a QUBO. We first expressed the QUBO as a function of 64 variables using SymPy. Then we turned it into a 64 by 64 matrix using NumPy. Today we'll validate that our conversion process from puzzle to NumPy array is correct. We're going to do that using a software package from Quantum Computing Incorporated called Mukai. Mukai includes a classical heuristic for finding the minima of a QUBO. That's exactly what we need for our validation. If we did our conversion correctly, the minima of our QUBO will correspond exactly to solutions of the StarBattle puzzle. So we're going to ask Mukai to find minima of our QUBO and then check whether they actually solve the puzzle. Here's our complete program. I didn't show you this last week, but after creating the NumPy array, I saved it out as a pickle file. So the first step of today's program is to read in the pickle file, which contains the NumPy QUBO. The next section of code converts the matrix to a flattened list, and then uses the Python built-in counter to form a dictionary containing the different values appearing in the matrix, and how many times each value appears. The last section invokes the sample QUBO method from the Mukai API. The first argument is the NumPy QUBO. The second argument instructs Mukai how to find samples, and the third argument tells Mukai how many samples to generate. Here's the output from running the program. The first line of output displays the counter. Of the 4096 matrix elements, almost 2700 are 0. And the rest are small positive and negative values. The next few lines come from Mukai as it validates the objective function and passes the QUBO to its server. After a few seconds, we get back a response. The response consists of more than 1,000 samples, which are sorted in order of increasing objective value. The first sample has the lowest value. That's the one that should solve our puzzle. At the bottom of the screen is a list of energies. These are just our QUBO evaluated for the samples listed above. And beneath that are the number of occurrences for each sample, since Mukai can return a given state more than one time. How do we know that we have gotten the correct answer? We simply grab the lowest energy sample and reformat into a square grid. If we compare the sample with a puzzle solution, we should see the ones in the sample correspond to stars in the solution, and the zeros correspond to blank cells. The fact that the lowest energy sample solves our puzzle confirms that our conversion from puzzle to QUBO is correct. Next week we'll convert our QUBO into an Ising model so that we can run it with Qiskit on a gate model quantum computer. That's it for today. Thanks for watching. Bye everybody.